So now let us dive properly into the steps in hypothesis testing. So briefly put, the following are the steps in hypothesis testing, and we commonly use the acronym PHANTOMS. So you state the parameter that you are going to be measuring or estimating or calculating in your study. State your hypothesis, both the null and the alternative. State the assumptions by which your data there. Name the test, the statistical test that you will be using in your study. Specify the test statistic that will be calculated. Okay, be a z-test or t-test. Specify the test statistic that will be calculated. Obtain the p-value. Make a decision and state the conclusion in context. Okay, we will go through these steps one by one. And for this, let us use an example of two groups of patients with coronary artery disease. Either they have undergone percutaneous angioplasty or coronary artery bypass graft. So whether they have undergone PTCA or CABG, and we have measured the average duration of hospital stay among these two groups. So we will follow the steps of hypothesis testing one by one using this example. First, state the parameter that you will be trying to estimate. So I am trying to understand what is the average duration of hospital stay among patients who undergo PTCA versus patients who undergo CABG. So my measure, or the measure that will be calculated, is the average duration of hospital stay with the standard deviation in both the groups. This is what will be the parameter that I am trying to estimate in my study. Now we come to stating the hypothesis. So you state your null hypothesis, your alternate hypothesis, and as discussed in the previous lecture, we state them in the form of measurable indicators. So we will see how it is done. So here my hypothesis is that the type of procedure that a patient with coronary artery disease undergoes influences the average duration of hospital stay. So my null hypothesis will be that there is no association between the type of procedure that a CAD patient undergoes and his or her average duration of hospital stay. What will be the alternate hypothesis? My alternate hypothesis just says that the type of procedure that a patient with CAD undergoes influences or is associated with the duration of hospital stay. I am not saying which of the two procedures leads to a longer or shorter hospital stay. Okay, so this is a two-sided hypothesis. So let us look at the values that are consistent with the null hypothesis, assuming that I am calculating the average duration of hospital stay. So I am saying that if I calculate the mean duration of hospital stay in the PTCA group and the mean duration of hospital stay in the CABG group, they are going to be the same. Mu1 is equal to mu2 is my null hypothesis. So mu1 minus mu2 will be 0. My alternate hypothesis is simply stating that mu1 is not equal to mu2. So mu1 minus mu2 is not equal to 0, since this is a two-sided alternate hypothesis. Assumptions. Now here I'm working with the assumption that the patients have been randomly sampled into my study. So there is random sampling that has happened, and that the mean duration of hospital stay in both the groups follows a normal distribution. These are the assumptions that I am going with. Now the next step is for me to name the test. So I am dealing with two means, and I know that the sample is a random sample, and the mean duration in both the groups is following a normal distribution. So let us say I have to compare means from two samples, and so I have gone with independent t-test. So that would exactly be the next step where I calculate the test statistic, in this case a t-statistic. So we all know how the independent t-test is done, and the end of it you have a t-statistic. The next step is hypothesis testing. So this you can do by two methods. So one is what you call the critical value method, and two is what you call the p-value method. We will look at them one by one. So where we stand is that you have a test statistic in your hand. So if you have to use the critical value method, you have to state what is the significance level that you have chosen. Now we saw in our earlier lecture also A significance level is something that you state upfront, which is your alpha value or the allowable alpha error value. Let us say it is 5%. And I'm allowing a 5% chance of type 1 error. My significance level is 0.05. Now, I have to look at the distribution and try to understand the critical value, which is defined by my significance level. So, I'm looking at this particular distribution and I identify the limits of values. Say alpha of 0.05, because I'm using a two-sided test, gets split as 0.025 on either sides of the distribution, and I make note of the critical value on the x-axis that is consistent with this significance level. Now, I look at my test statistic. Does my test statistic fall beyond this critical value? It could be on either side of the distribution because I've chosen a two-sided test. So, if my critical value falls below or beyond this critical value on either side of the graph, then I would say that my null hypothesis stands rejected. Okay, so this is if you choose to use the critical value method. Now, let us say you are using a p-value method. More on that a while later. But so in a p-value method, you decide on a significance level, you compute the value of your test statistic, and you determine the p-value that is consistent with this statistic. So you have your t statistic, you go to the t distribution table and you look at, the first and second decimal point, and the value that is shown in that distribution table is the p-value that is consistent with your test statistic. So I would repeat, in the critical value method, based on your significance level, you identify the critical value on the distribution, and your test statistic should fall in the region beyond if it is on the right hand of your tail, and below this critical value if it is on the left hand of the tail. If it falls in either of these regions, then you stand to reject your null hypothesis. Whereas if you are using a p-value method, then you look at your test statistic in the appropriate distribution table, if it is a t statistic or a chi-square statistic or a z statistic, and you look up that particular value in that particular table up to 2 decimal points, and you will have the p-value in that table. So when we do the hypothesis testing by critical value method, you can look at an example. Say if you're looking at the z table, and if my significance level is 0.05, which is 0.025 on either sides, then you know that the critical value on the x-axis for this particular significance level is minus 1.96 and plus 1.96. So if your test statistic is falling in the regions as shown in this particular graph, then you reject the null hypothesis testing. And this is the example of a t table. So when you have the test statistic, you look up the t table for your test statistic and find the p-value as indicated in this graph again. So what is this p-value? So going by the proper definition, p-value is the probability, assuming that the null hypothesis is true, that the observed data will depart from an absence of association to the extent that they actually do, or to a greater extent. I will repeat, assuming that the null hypothesis is true, what is the probability that you get the results that you have obtained in your study, or a more extreme value than the ones that you have obtained in your study? So I think it is quite obvious that we are looking for a much lesser probability. So this p-value has an arbitrary cutoff, a universally agreed upon cutoff of 0.05. We have agreed that this value should be as low as possible for you to reject the null hypothesis, and the arbitrary cutoff that we put is 0.05. So when you look up the p-value for your given test statistic in the appropriate table and it comes to a value less than 0.05, it is enough evidence to say that the results that you have got in your study are not consistent with the null hypothesis. So you will be rejecting the null hypothesis. So we've done the hypothesis testing and we've obtained a p-value. Now it's time to make a decision. So you have a p-value less than 0.05, let us say, and it is time to reject the null hypothesis. So in our example, let us say I calculated the mean duration of hospital stay in the PTCA group and the mean duration of hospital stay in the CABG group. I subtracted them. Then I knew that I had to use the T statistic to compare these two means. And I looked up the T statistic in the p-value table corresponding to the T distribution. And I have a p-value of say 0.04, a two-sided p-value of 0.04. So now in decision that I have to make is about whether I have to reject or not reject the null hypothesis. So my decision would be that since the probability of getting a mean difference as extreme as or more extreme than what I have in my results when the null hypothesis is true is 0.04. Now, let us remember that this is less than the arbitrary cutoff of 0.05 that we've chosen. So now I choose to reject the null hypothesis. So the next step would be to state your conclusion in context. So we've decided to reject the null hypothesis. So what does this mean in your context? This means that the average duration of stay if the patient undergoes PTCA is significantly different from if his duration of stay if he undergoes CABG. Okay, so this is stating your conclusion in context. So we will go through once again the steps of hypothesis testing. You state the parameter of interest. You state upfront your null and alternate hypothesis. You list out the assumptions that we are making before we rush into statistical tests. You name the statistical test that you will be using. You calculate the test statistic. You obtain the p-value. You make a statistical decision and you state your conclusion in the context of your research. A small thought exercise for you on hypothesis testing. Now, let us assume my research question is the association between condom use and testing positive for syphilis. So, if this is the research question, I would like you to, put yourself through a thought exercise of stating the steps of hypothesis testing and come to a point on stating the conclusion in the context of the given research. Now, let us say we're done with hypothesis testing. I've made a decision to reject or to not reject my null hypothesis, and I am pretty much sure of what conclusions I've arrived at in the context of my research. Are we to say that we are completely error-free? No, there are some errors that can still creep into your epidemiological studies. We will see the two key errors that we commonly encounter in epidemiological studies. So these are called type 1 error and the type 2 error, and how they creep into your study and what implications they can have for your study results is what we will see over the next few minutes. Now, let us say I have rejected the null hypothesis after I followed all the steps in hypothesis testing. But the universal truth or the actual truth, which I'm not aware of, is that the null hypothesis is true. So I have rejected the null hypothesis when it actually is true. When I make this error, this is called a type 1 error. So this is also called the alpha error, and you would like to recollect that this is what we chose, or this is what we specify in the beginning itself as the significance level. So if I say that my significance level is going to be 5%, that means I'm allowing a 5% chance of a type 1 error. Or there is a 5% chance that I will reject the null hypothesis when it is actually true. So this is already specified. You already specify how much of this error is allowable in your study upfront in the beginning of your research plan itself. Now let us see the other error. I have failed to reject my null hypothesis when actually it should have been rejected. I repeat, I have failed to reject my null hypothesis when in truth I should have rejected it. Now this is the case when I am making what you call a type 2 error or a beta error. Put in other words, I am not detecting an association between an exposure and outcome when there is actually an association. Now this is beta. So 1 minus beta will be the ability to detect an existing association between exposure and outcome. Now that, if you remember, is what you call the power of your study. So the power of your study, which is the ability of your study to detect an existing association between an exposure and outcome, is 1 minus beta. So this is also something that you state upfront in your study before you go about planning it. So both the alpha error and the beta error are things that you specify maybe in your sample size calculation. You decide that my study will have 5% chance of type 1 error and say 20% beta error, or in other words, 5% alpha error and 80% power. So this is left to the researcher to state upfront at the beginning of the research. So this is a choice. Neither error is good. Both the errors are bad, but it is very specific and contextual to a research question as to how much error is allowable in answering that particular research question. Thank you.